this video, we're going to talk about converting equations that are in slope-intercept form to standard form. And standard form looks like that, where a, b, and c are all integers, which means in standard form you cannot have fractions or decimals. So one little thing that I like to do ahead of time is get rid of the fractions and decimals. In example A, we have a line with a slope of 3/4 and the y-intercept is a point 0, -5. So when we get rid of the fraction that's in the slope, one way we can do that is to multiply the entire equation by the denominator. Since the denominator is 4, we're going to multiply the entire equation by 4. And that means multiplying every single term by that 4. So we're going to take 4 times y, which leaves us with 4y. We're going to take 4 times 3/4 x, and that will become 12/4 x, or 3x. And then we're going to take 4 times that, -5, which is -20. Now we have an equation. It's equivalent to the first one. It's just that now we have no fractions, which in standard form you cannot have any fractions. The other thing that's true about standard form is the x and the y are on the same side of the equal sign and the constant is on the other. So we are going to move the 3x by subtracting it. Since we're moving the entire term, not just the 3, not just the x, we're moving the 3x. So we are subtracting that from each side. And then, to make it look like standard form, we've got -3x plus 4y is equal to -20. And that equation is now in standard form. Now, there are some teachers, and you may run into this in college or maybe even here at South, where they believe that the a value, the coefficient on the x, in order for it to be standard form, must be positive. Personally, I don't care. If you leave that answer, -3x plus 4y is equal to -20, if you leave it like that, you will be fine. But for some teachers, they want that x value to be positive. So if that is the case, the only way we need to make that positive is to multiply everything by -1, or make it 3x minus 4y is equal to +20. These two equations would be equivalent. As far as this class goes, and as far as I'm concerned, this answer right up here is perfectly fine. You don't have to do anything else. But there are a few people out there who believe that a needs to be positive, so then you would need to write it like the second one. Either way, I don't care. And once again, this is a reason why in some of the directions you would see write an equation, not write the equation. Now, for our second one, example B, we have decimals involved. Okay? So to get rid of the decimals, if we got rid of all the decimals, we would essentially have to move each one over once. Well, to move the decimal point to the right one place, you would have to multiply everything by 10. So then once we do that, multiplying the entire equation by 10, that includes 10y equals 91x plus 36. And remember, you have to get rid of all decimals in the equation. So now we've gotten rid of all decimals. Now we just need to get the x and the y on the same side by subtracting the 91x. And in order to do that, we have -91x plus 10y is equal to 36. And once again, I wrote that in the wrong color. That's okay, pretend that's blue. I don't know, I'm kind of big into my different colors if you haven't noticed that yet. So, pretend I remember to write that all in blue. Okay, so negative 91x plus 10y is equal to 36. And again, if you run into those people who feel that that a term has to be positive in order for it to be in standard form, just change the sign on everything. Essentially, multiplying everything by negative 1. And then the next equation, or the next video, we will be discussing graphing lines out of standard form.